Hello, and welcome to the lab directions for Lab 4, titled The Apparent Retrograde Motion of Mars. Alright, so this is of course for Astronomy 20, or whatever class you're watching this video for. Okay, so this lab is all about using a program called Stellarium in order to do some simulation observations of the apparent motion of Mars in Earth's night sky. Okay, so I'll talk about the program in a second, but please take a look at the pre-lab. The pre-lab is all about looking up information. So you're just going to look up some terms and you're going to report that. All right, but let's take a look at Stellarium. Okay, the main focus of this lab. Okay, so here I have it open in the browser. So this is just going to the website that's included in the lab. And we can see it's got a landing page. There's a web-based version, but doesn't have the functionality that we need for this lab, so we won't be using it. Instead, you're going to want to download a version of the lab that's appropriate to your operating system. All right, so you can see some options there. I downloaded this one here. Okay, and then I'm going to go ahead and run the program. All right, and there's an introduction to the lab, and it kind of gets into how to set things up so we can do our observations. And I don't want to show you everything because a big part of the lab is kind of, going through and exploring how to use Stellarium, but I just want to get you started so you don't feel like you're overwhelmed with just, how to do it. By the way, I'm just scrolling down to show you that this is what you actually be turning in. Here is where you'll enter the pre-lab information. There's some space to answer some other questions, a table to fill in based on observations from the simulator, and then finally some other observations you're going to make, and then that's it. The last page is just some convenient shortcuts for using Stellarium, right? So if maybe you'll want to have some fun, messing around with the night sky simulator, and they'll help with this lab too. Okay, so that's the answer sheet. That's what you're going to turn in. But let's scroll back up to the top and get started actually using the program. All right, so I'm going to go ahead and start it up. Okay, it's just sitting here in my downloads file, and I'm just going to open it. The first time I opened it, my operating system asked if I was sure I wanted to open it, and I said yes. Okay, so notice this is kind of the basic setting when you turn it on. And as the lab points out, you want to turn off some of these features. So you want to go here and exit full screen mode. I wouldn't worry about that. I go ahead and leave it in full screen mode, but you definitely want to remove the atmosphere, remove the cardinal directions, and remove the simulated ground. Okay, so let's go ahead and do that. Okay, so we'll go up here. So I'm just going to go over here. This is going to be the atmosphere. I'm going to get rid of that. I'm going to get rid of the ground. All right, now I can basically see all the night sky. And then we get rid of the cardinal directions. Okay, and then the next thing it mentions to do is then turn the type of viewing mode to this one here, which is called an azimuthal mount as opposed to an equatorial mount. And that's just going to be able to kind of keep things fixed in a way that will be a lot easier to understand. Okay, so let's go back to Stellarium. So that's going to be this option right here. Okay. All right, so here we're looking at the whole sky, not worrying about Earth's atmosphere. Basically, this is how the night sky would look if we were at a location in the solar system where Earth is, but we weren't at Earth, right? So we didn't have the light of Earth to obscure our view of the sky. All right, there is the moon. Go around and look at other objects in the sky. All right, there's the sun. Okay. And the first couple questions are going to be about Venus and Mercury. And Venus and Mercury are always near the sun, so they're pretty easy to find if you can find the sun. You can also just use some zoom features. I'm just using a two-finger zoom in and out. All right, and then I just click and drag to move around in the night sky. Okay, kind of depends how you've set up your trackpad or mouse, but I'm sure you'll figure out how to navigate through the sky. But again, here's Mercury and Venus. First few questions refer to those. So let's go ahead and take a look what's going on. So right now, the night sky is progressing at its normal rate. See, so we're just moving at a rate of 1 second. So not much is happening, right? But we can speed up the night sky. Okay, that's one of the things you're going to do is you're going to make it run faster. So that would be right here. Okay, so if I click on it once, it runs a little bit faster. Click on it twice, it runs faster still. And I can just keep clicking on this fast forward button and it just keeps moving faster. All right, and then eventually we see that, sure enough, wow, it's moving really fast. And we can clearly see the motions of the planets. So you look at this. Look at this, right? Whoa. Okay, look at Venus and Mercury. The thing that keeps zooming by is the moon, making an orbit every 27.5 days. Okay, there's Mars, right? The second half of the lab refers to Mars. Let's go ahead and pause things. All right, so that's the idea. You're gonna want to. You don't have to have it run that fast. It recommends you kind of run it for about 2 years. Let's see how I went. I went for about a year and a half because we're in 2021. Actually, no, I only went for about 6 months because we're in 2021 in July. All right, so next summer. All right, this is how the sky would look. Okay, and the relative orientation of the planets and so on. All right. So another thing that you're going to want to do in the lab, let's refer back to it, is you're going to make some observations, ask some questions about Mercury and Venus, and you definitely want to think about those. So you're just using the features I mentioned in some sort of fast forward mode. Then you can go on. Then you're going to look at Jupiter and Saturn again, answer some questions, and about this idea of retrograde motion, a term you're going to have to look up. Then you're going to get on the Mars. So a couple of things about Mars is it wants you to turn on the constellations. So let's show you that. So constellations can be turned on by clicking on this link here, constellation lines. Okay, that does that. All right, we can turn on constellation art as well, but it's kind of gets in the way, so I wouldn't do that unless you just need a quick. Maybe it can help you find something quickly, but then you can turn it right back off. Right, so like that. All right, and then I guess what I wanted to point out is that then there is another feature here. It mentions that you're going to want to kind of track the Mars, okay? And you're going to click on Mars to get the information in order to fill in one of those tables. It's very specific about the information you want. You want right ascension declination. You want the name. You want size and distance, right? That's basically the information you'll be putting in. You don't have to uncheck the other boxes, but you can just ignore that extra information. So let me show you what that looks like. So let's go ahead and click on Mars. Mars is small right here. So here's all that information, okay? And you just want to look for the stuff that you care about. Right, because you can see there's a lot, elongation, phasing, all kinds of stuff, illumination, right? But you're only going to be reporting the specific bits of information that you were asked for. It sure is a lot, isn't it, right? Albedo, which is the reflectivity, okay? All these features, okay? And then the last thing I want to mention, one of the last things, is this Shift T thing here. And this has to do with actually tracking the planet. So let's go back to Mars, okay, where we have it clicked on. I'm going to go ahead and start kind of fast forwarding in time again. We'll kind of go at a pretty fast rate. All right, see that? And then I'm just going to do Shift T. Okay, I'm going to zoom in a bit on Mars too. Let's zoom in. Okay. And what's going to be happening now is now we see, look at that. See that little line that's forming? That's because since I clicked Shift T while Mars was selected, it's actually then showing the path of Mars. We can make it go even faster, and there it is, right? So that's going to be great for answering some of the questions. That's why it tells you to turn on that feature. Okay? And so that's going to help you answer, basically when does retrograde motion occur, and that line will really clearly show you Mars's path during apparent retrograde motion. Okay, and then there's some questions about what are particular dates, and it has you start on a particular date in June, so you can just follow the directions there. All right, and then you're going to fill in the table. Okay. So the last thing I want to mention is number 13. It mentions to go to a simulation other than the night sky simulation Stellarium. Instead, it's just a little program that's web-based on this particular website here. This is actually the same website that we've used for labs before, NAAP. Okay. So I went ahead and opened up that simulation here in Chrome. It works well in Chrome and Firefox. It doesn't. It's hard to get Flash to play in Safari, so I'd recommend using a different browser. Firefox is probably the best, but it was working in Chrome. Although Chrome does say it's going to stop supporting Flash by I think at the end of this year. But we should be good for this semester. But moving forward, Firefox is the best browser to use. And then you see here that I've just this is just a simulation, as the lab mentioned, is a simulation of the planetary configurations. You can basically create any kind of virtual planet you want by specifying some quantities of that planet based on Kepler's laws. And then you can also turn on the real planets here. And then we can clearly see Mercury, Venus, Earth, and Mars. And we can start the animation. And what's great about this animation that Stellarium doesn't do, or at least doesn't do based on the way we were using it, is it kind of shows this bird's eye view of the solar system. And so we can see the distance between the planets rather than just what the night sky looks like. So, just to kind of reiterate, right? So Stellarium is really good for simulating the night sky from Earth. Of course, in this case, simulating the night sky in a convenient way where I've turned off the atmosphere and turned off the ground. But regardless, a bit of a simulation. Whereas this one here is, as if you could send a space probe, a couple 100 million miles up into space and you have a bird's eye view of the solar system. This is what it looked like. All right, cosmic bird, that is. Okay. So again, that will allow you to answer the questions in the lab, as it says. It says, the simulation will allow you to answer questions about how far is Mars from Earth at conjunction and opposition. Okay. And then you can obviously look at those terms, and they're kind of clear in the context of the lab itself. All right, so that is it for the lab. It's a new bit of software. Definitely kind of adding to our suite of simulations, some new ideas. In particular, this idea of apparent retrograde motion, which is an important historical and I just think genuinely interesting idea in astronomy, and especially observation-based astronomy. Okay, so if you have any questions about the lab as you're working on it over the next week, please feel free to message me or contact me through office hours, and I'll be on the lookout for that. So thank you so much for watching this directional video, and I will talk to you all soon.